Here we'll be looking at the concepts of corresponding parts of those congruent triangles are congruent. We learned if two triangles are congruent, then the corresponding parts of those congruent triangles are congruent. In other words, if you have proven that the triangles are congruent, then every piece of the triangles will also be congruent. So these last couple of days we spent proving using SAS, SSS, ASA, and AAS that triangles are congruent to each other. Well, once we've done that proof, we can go a step further and compare different parts that we didn't originally know about. So the way we're going to abbreviate this in our proofing is corresponding parts of congruent triangles are congruent. That's at least how I have my class do it. If we remember our corresponding parts, we have angle A is congruent to angle D, first to first. Angle B is congruent to angle E. Angle C is congruent to angle F. And that's really important when we write these congruent statements with triangles later on in our proofs, that we understand what letter goes where. Segment AB would be congruent to segment DE, first, second, first, second. Segment BC is congruent to segment EF. And finally, segment AC is congruent to segment DF. So, is angle B congruent to angle E? Well, it doesn't tell you anything off the back about those. So we can compare them. We can see that we have side angle side. So that triangle BAC is actually congruent to triangle EDF by side angle side. So that means that angle B will be congruent to angle E because corresponding parts of congruent triangles are congruent. Same thing here. If we look at angle 1 and angle 2, we want to see if those are congruent. Well, first off, we know that BC is reflexive, so it's congruent. So we know that triangle ABC will be congruent to triangle, let's see, 1, 3, so DBC by side, side, side congruence. Therefore, angle 1 will be congruent to angle 2 by corresponding parts of congruent triangles are congruent. So that's how we use that new theorem to prove different parts. Okay, let's look at a couple proofs then, because that's really the bulk of this. Here I have AB is parallel to ED, and AB is congruent to ED. Now, if you feel comfortable with this proof, why don't you pause the video and try it, and see how far you can get without my help. All right, we're going to draw a little line across the page. We know by looking at this that we have vertical angles here. So angle ACB will be congruent to angle DCE. Because these lines are parallel, that means that alternate interior angles will also be congruent. So it looks like I can prove these triangles are congruent by using angle, angle, side. So let's write out the proof. AB parallel to ED. That's our given. We have AB is congruent to ED, and that's another one of our givens. And we also used the fact that we had vertical angles in this problem. So angle ACB is congruent to angle DCE, vertical angles. So from our parallel lines, we learned that angle ABC was congruent to angle DEC. That's because if the lines are parallel, then alternate interior angles are congruent. And so I have two angles and a side. So I join those three together and I say triangle ABC is congruent to triangle DEC. And that, as we discussed, is by AAS congruence. Notice it doesn't ask you to prove the triangle is congruent, but in order to show that BC and EC are congruent, I need to know that the triangle is congruent. Because now that I know the triangle is congruent, I know that BC is congruent to BC because corresponding parts of congruent triangles are also congruent. All right, this proof here is a little more involved. So once again, pause the video and see how far you can get on your own. All right, let's give it a try here. I have BE and AD bisect each other. In other words, BC will be congruent to CE, AC will be congruent to CD, and I have vertical angles right here in the middle. So it looks like I can prove that these triangles are congruent using side angle side congruency. So let's do it then. We got a big old given at first that we can put in the box there. BE and AD bisect each other. I know the handwriting is kind of messy, but I'm just copying in. Given. Also up top, I got the fact that angle ACB is congruent to angle, let's see, DCE. And that's, of course, by vertical angles. From this first bisecting box, I have two different items I can put there. First off, I learned that AC was congruent to DC by definition of bisector. The bisector will cut something in half. Also that BC is congruent to EC. Same reasoning. So I take this box, and this box. I can join them up to say that triangle ABC is congruent to triangle, let's see there, DEC. And that, of course, is by SAS congruence. Now, hopefully you got that far. Here's where you might have taken a part where you're like, okay, I have no idea what to do. Well, if these triangles are congruent, angle A will be congruent to angle D by my congruent statement. So I can write that over here. Sorry, I'd write down, except for I don't have a ton of space here. Usually on your paper, you should try to flow downwards. So I can write angle A is congruent to angle D because corresponding parts of congruent triangles are congruent. If A and D are congruent, those are alternate interior angles to these two lines. And if alternate interior angles are congruent, then the lines are parallel. So I can say AB parallel to DE because if alternate interior angles are congruent, then the lines are parallel. And that's how you do a little more involved proof there. Let's look at one last problem. And this is going to bring back an old friend we had from the first 6 weeks. So pause the video and see what you can do with it. All right, let's mark it up. AB parallel to CD. AB is also congruent to CD. And AF is congruent to HD or DH. You might remember back the first 6 weeks, we learned something called the common segment theorem. Where if I have two segments, so AF and HD, for example, that are congruent, and I add the same segment to both of them, FH, those segments remain congruent. So using the common segment theorem, I can actually say AH is congruent to DF. And of course, using these parallel lines, I can say this angle is congruent to this angle. So it looks like I have side, angle, side to prove here. So let's write out this proof. So given AB parallel to CD, AB is congruent to CD, AF is congruent to DH, and let's go ahead and write given under all of those, of course. And finally, the last thing I need to put on here is that FH is congruent to itself, and that, of course, is our reflexive property that we can put on there. And that's so I can use the common segment theorem. So AF, DH, FH, FH, I can join those together, and I can say AH is congruent to DF by the common segment theorem. Get used to that. We're going to see that quite a bit more in the upcoming parts of this unit. So AB parallel to CD, I come down here and say angle A is congruent to angle D because if parallel, then alternate interior angles are congruent. I take these three items, I join them together, and I can say triangle ABH is congruent to triangle DCF. And that, of course, we decided was by side angle side congruence. And of course, if those are congruent to each other, then all I need to write now is BH is congruent to CF, and that is by corresponding parts of congruent triangles are also congruent. All right, well, please study those theorems and make sure you get them down. Thank you for watching.